Hi, in this video we're going to look at solving simultaneous equations, and we're going to do this using the elimination method. This is a GCSE higher topic. As ever, for more information you can follow me, Mr. G. Walton, on Twitter or at Tupton Maths for further information, and you can ask questions regarding the video or just general maths questions, and we're always there to help. Okay, let's have a look, see what we're going to do in this video. So by the end of the video you should be able to solve simultaneous equations by this elimination method, and we're going to do that by either adding or subtracting the two equations together to get rid of one of the variables. It might be that before we can do that we might have to multiply one of the equations to enable us to eliminate one, or it might be that we need to multiply both equations by something before we add or subtract to get rid of either the x or y or whatever the value, whatever the letter is that we're trying to eliminate. Let's have a look at an example. So in this example it says solve algebraically these simultaneous equations. We've got two equations, 3x plus y is 3 and 2x minus y is 7. Now if we only had one of these equations, 3x plus y equals 3, there are loads and loads and loads of different values of x and y that mean that this is true. For example, here x could be 1 and y could be 0. That gives 3 times 1 is 3 plus nothing is 3. That works. We could have that x is 2 and y is minus 3. 3 times 2 is 6. Take 3 is 3. Now, for one equation with x and y in, it doesn't make any sense to try and solve it because there are so many different answers. In fact, there's an infinite number of answers. But when we have a pair of simultaneous equations, what we're actually trying to work out is what value of x and y means that this first equation is true, and also the same values for x and y give this second equation here. Now actually what's happening here is it's two different equations of lines. This is a linear equation of a line, this is a linear equation of a line, and what you're trying to do is work out where these two lines cross. The coordinates, the xy coordinates of where these two lines cross. Okay, let's have a little go and see how we're going to do it then. Well, whenever we're doing this sort of an equation, simultaneous equations, I always label them up. So we've got 3x plus y equals 3, and we've got 2x minus y equals 7. I'm going to call this equation 1, and I'm going to call this one equation 2. Now what I'm going to try and do is get rid of either the x or the y to start with, because then I've just got one equation in terms of x's or y, and I can solve it. Now I'm hoping that you can see here that we've got a 3x and a 2x, we've got a plus y and a minus y, and a 3 and a 7. Now if I add these two equations together, what will happen is the following thing. So I'm going to add equation 1 to equation 2. 3x plus 2x gives me 5x. If I add together a y and a minus y, I get no y's at all. So I've got no y's now. I have to keep adding though. I can't just add bits and ignore other bits. I've now got to add the numbers at the end. 3 and 7 is 10. This gives us a new equation. The new equation is 5x equals 10. That means that x must equal 2. 2 times 5 is 10. Now once I know what my x value is, I can write it on my answer sheet. I can also then work out what my y value is by substituting this value back into either equation 1 or equation 2. I'm going to pick the one with the smallest numbers, and actually in this occasion it's going to be easy to do on both. I'm going to pick equation 1 only because it's got a plus sign in it, and that just means that from my point of view I think I'll find it easier to do, whereas if I did the minus sign I might find it a little bit more tricky, but either way I'm going to get the same answer, so it doesn't matter. Substituting back into 1 then, so I'm going to sub into equation 1. I've now got 3 multiplied by 2 instead of x plus y equals 3. That means 6 plus y is 3. 6 plus something is 3. Well, y has got to be minus 3. So I've now got my y value as well, which I can write in for my answer. So x is 2, y is minus 3. And what this is saying is that these two lines cross at the coordinate 2, minus 3. In this case, then, it's not asking you to do anything to do with the graphs, but it's worth knowing this information in case you're given a question that's got the graphical representations of the lines rather than the equations. Okay, let's have a look at a second example. In this example, we've got two equations again. Equation 1 is 2y plus x equals 9, and 3y minus 5x equals 20. Now this time, I can't just add the two equations together. Here's equation 1, here's equation 2. I can't just add them together, because if I did, I'd end up with getting here 5y. If I add this, I'll get minus 4x equals 29. Well, I've still got y's and I've still got x's. I've not eliminated anything. What I'm going to have to do is to multiply one of the equations by something to enable us to, when we add them or take them away, it means that we end up with no y's or no x's. And I'm being quite vague about saying or this or that, but that's because there's lots of different ways of doing these questions. What I'm going to suggest is that we take equation 1 and we multiply it all by 5. Now that means multiplying every single term by 5. If we do that, this becomes plus 5x, and then I'll have a plus 5x and a minus 5x here, which I can eliminate. So I'm going to take equation 1, multiply it by 5. That's going to give us 10y plus 5x equals 45. So I've got a new equation, this one. I'm going to call this one equation 3. I've made a new equation. Now I've not created it out of nowhere, I've just scaled it up, and because I've multiplied the first, second and third term all by the same number, it's equal. This is equal to the first one. Okay, so if this is my new equation 3, what I can do is I can take equation 2 and I can add equation 3 to it. The reason I'm adding it again is because I've got a minus 5x and a plus 5x. If I add 5x to minus 5x, I end up with no x's, and I've eliminated one of the variables. So if I'm adding these two things together, I get 13y, no x's because I've added my minus 5x and my plus 5x, equals 65. Now what I can do is I can divide both sides by 13, which means that y is 5. I've got one of the answers, so I can write in y equals 5. Now to get the second part, and it's easy to forget this, I can now say I can substitute this back into one of the equations. I'm going to sub it in equation 1, which gives me 2 times 5 instead of the y that I had before, plus x equals 9. So 10 plus something equals 9. That means that x has to be minus 1. So here we have x equals minus 1. I've managed to get two values. I've found the coordinates of where these two lines cross. They cross at minus 1, 5. I've solved it simultaneously. Example 3 looks like this. I've got equation 1, 2x plus 5y equals 1, and 3x plus 2y equals 7. Again, call it equation 1 and equation 2. Now, I'm looking at these two equations and I'm trying to find a way to multiply one of them by something to equal the other value. And it could be either way. I might be multiplying equation 2 to equal equation 1 or vice versa. And I can't see any whole numbers that I can multiply this by to get to this, or this to get to this, or this to get to this, or this to get to this. So what I'm going to have to do is multiply both of them by something. Let's see what we can do. And again, this is entirely up to you. I'm going to try and get rid of my y's here. Not for any particular reason other than I think I prefer to get rid of these middle, if you like, variables. It's just a way that I always do it, and you'll find your own way that you get comfortable doing, although any way that you use that gives you the right answer is okay. Okay, what am I going to do? I'm going to multiply this one by 2. Why 2, you might think? Well, that's the value here. And if I multiply this one by 5, and again, why 5? Well, because it's that one, I end up with 10y on both. So let's multiply equation 1 by 2. That's going to give me 4x plus 10y equals 2. And I'm remembering to multiply every single term, not just bits of it. Second one, equation 2, I'm going to multiply by 5. So I've now got 15x plus 10y equals 35. I'm going to call this new equation 3 and this one equation 4. Now in the past, what we've said is that we can look at adding two equations to get rid of them. If I add both of these equations, I'm going to get 19x and 20y and 37. That's not going to help me. What I can do though is take one equation away from the other equation. And what I tend to do is pick the equation that's got the biggest x variable here, or the biggest x coefficient, and take the smaller one away from it. So actually what I'm going to do is equation 4 minus equation 3. And I'll write it up here so we can see. We've got 15x plus 10y equals 35. And we're going to take away 4x plus 10y equals 2. I'm left with 11x, no y's, equals 33. That means that x is 3. I've worked out my x value. Once I've worked out my x value, I can substitute that back into either equation. It doesn't really matter. I'm going to pick equation 1. I've now got 2 times 3 instead of the x that I had before, plus 5y equals 1. 6 plus 5y equals 1. I'm going to take 6 away from both sides, so 5y equals minus 5, so y equals minus 1. And these are my two values. Remember, if we were asked to find where these two lines cross, they would cross at 3 minus 1. Okay, so we've seen different ways of eliminating the variable, either eliminating x or eliminating y. We've looked at adding them in the first couple of instances because the signs, I had a positive and a negative sign. We've looked at taking them away, like we did here, because the signs were the same, so I've taken one away from the other. I'm going to give you an example of a question where you can have a go yourself next. Here we go. In fact, there's two questions here. There is one question on the left, one question on the right. I'm going to split the page in two. I want you to have a go at both of them and then pause the video and I will show you the answers in a minute. Okay, so the one on the left, we've got this equation here. So we've got x plus 3y equals 8. So equation 1, x plus 3y equals 8. And we've also got 5x minus y equals 16. 5x minus y equals 16. I can't just get rid of the variables because I have no numbers that are the same. So if this is equation 1, this is equation 2, I'm going to multiply equation 2 by 3. That gives me 15x minus 3y equals 3 16s are 48. I'm then going to take my other one, x plus 3y equals 8. Thinking about what to do with these, I'm going to add them together. So that's going to give me 16x equals 56. And we're going to divide 56 by 16. And we're going to get 3.5. So x is 3.5. Okay, now I've found my x value, I can substitute it back in to work out my y value. If we do it in the first equation, then I've got 3.5 plus 3y equals 8. Take 3.5 away from both sides, so 3y equals 4.5, and divide by 3. 4.5 divided by 3 equals 1.5. Now, don't worry that you've got fractions as answers. That's perfectly possible that you can cross two lines at a fractional answer. And again, with higher work, it's quite feasible that this might be the case. So we've got x is 3.5, y is 1.5. On the second question, we've got these situation: 2x plus 5y equals 8, and 4x minus 3y equals 3. You can do this in one of two different ways. Again, I'm going to pick my getting rid of my y values, but you might have spotted that you could multiply this by 2 and have a 4x and a 4x. Doesn't matter which way around you do it. I'm not going to do it that way. I'm going to multiply this equation by 3, multiply this equation by 5. That's going to give me two new equations. 6x plus 15y equals 24. And what am I going to do next? 20x minus 15y equals 15. Now I'm going to add these two equations together, which gives me 26x equals 39. Divide one by the other. X is going to give me, so 39 divided by 26 is going to give me 1.5. Substitute that back in. I'm going to substitute it into equation 1. So I've now got two lots of 1.5 plus 5y equals 8. That means that I've got 3 plus 5y equals 8. That's take 3 away, so 5y equals 5. That means that y equals 1. So the two solutions I've got are x equals 1.5 and y equals 1. Okay, so as ever, if we're taking notes for our revision cards, if we're solving simultaneous equations, the elimination method, you need to do the following things. You need to look at finding the coefficient, that's the number in front of your variable you're trying to eliminate, to see whether you can add them or subtract them. You add them if you've got different signs, subtract them if you've got the same sign. Be careful that if you're doing that with a number at the front, so if you've got, for example, 4x minus 2y equals 7 and 4x plus 6y equals 9, if you were going to add these, you end up still with 8x and you end up with 4y. It doesn't really help you, but you could take one away from the other. That would get rid of your 4x's, because these are both positive. Okay, so if they're the same sign, you can subtract. If they're the different sign, you can add. But you need to be careful which sign it is that you're looking at. We're not interested in this case, in this one. It's the sign in front of the thing you're trying to eliminate. If neither of them you can eliminate straight away, then you might have to multiply either one or both to get a variable to eliminate. And once you've done that, once you've solved it for one letter, either x or y, substitute it back in to get your other equation. Okay, hopefully this has been useful. I'm going to do another video on another type of simultaneous equation. That's the simultaneous equation where you substitute one in for the other. I'll show you that, and that's going to be called Simultaneous Equations 2. Okay, as ever, good luck with your exams. If you need anything, contact me on Twitter, and good luck. Bye.